Hi, and welcome to the second episode of our webinar series, Office Hours, where we are discussing the basic of industrial AI agents. In the last episode, we met with my colleagues to briefly discuss what industrial agents are, what they consist of, how they can be useful for our business, as well as some concerns related to using them and lessons learned from initial failures of industrial agents. We also briefly touched upon the implementation practices and how to build trust for industrial agents. Today, we will go a bit deeper into the details, where we will talk about the ingredients necessary to make industrial agents work. But first, just a quick reminder of what the industrial agents are. Simply put, an industrial agent is an entity powered by a language model that you can communicate with to solve a specific business problem, with the emphasis on specific. It consists of a language model with reasoning capabilities, a set of instructions that describe how the agent should go about solving a specific task, a set of predefined and industry-relevant tools that enable the agent to interact with its external environment, and of course, access to relevant industrial data as well as the user's context. So now we know what the industrial agent is, and we talked a little bit about how they can be useful for the business in the last episode. The question is now, what's required to actually make them work? We have been working on this for a couple of years now, where we have been conducting experiments and trying different approaches on real industrial use cases. What I'm going to share with you today is what we have found to be most efficient and promising way to make industrial agents work. Let's get into it. So, as I have already mentioned, language models are one of the main components in an industrial agent. Essentially, they provide the agent the capability to understand, reason about, and generate human-like text. And this is, of course, very big because they provide a simple interface for accessing complex industrial data, given that you have another important ingredient in place that I will get back to very soon. But first, I just want to highlight one thing related to language models in the context of industrial agents. As you know, there are many different language models out there, both commercial models and openly available models, or often referred to as open weight models. Sometimes these models are grouped based on their weight class, which essentially reflects the number of parameters they consist of, which can range from a few billion parameters to hundreds of billions of parameters. I don't want to go into all the details, but because my colleague Viba will be covering this topic in much more detail in the next episode. But the point I want to make is that different language models have different natures. They have distinct strengths and also weaknesses to some degree. They have different reasoning capabilities, often correlated with the number of parameters they have, and some might be better in certain domains than others, and so on. So let's say you have built a solution that is powered by a language model, and you replace that model with a different model. And if you don't change anything else in your system, you're really not guaranteed that you get the same results. And usually you don't. And sometimes, and even when you try to adapt the rest of the system to this new model, you don't necessarily get the same results. So to design effective AI agents, it's really crucial to carefully choose an appropriate language model with capabilities that are aligned with the intended use and objective of the agent. Typically, this is done by measuring the quality of the system on benchmark datasets that we briefly discussed last time. And in our case, we have been investing heavily in creating industry-relevant datasets for evaluating our solutions. And for us, it has been very important to use industry-relevant datasets because they measure what is actually relevant to us, not some abstract capabilities of the language model. But again, my colleague will be covering this topic in much more detail in next session, so I will cover the other parts. Based on our experience, another required ingredient to make industrial agents successful is a knowledge graph. And there are several reasons for why we believe this is essential, so let's try to break it up. First of all, industrial data, is extremely complex, and unfortunately, context is not inherent in industrial data. For example, if you have a set of data points of a sensor value over time, it doesn't really provide much insight without additional context. It's first when you add more context to the data that it really becomes valuable. The context can, for instance, be information about what the equipment is, which other equipment it is connected to, where it is located, any documentation that is linked to the equipment, explaining or describing what's normal operation range, and so on. It is first when you put all this information in context inside a knowledge graph that you get a better understanding of the situation, and this, of course, gives you a much better decision basis. This is true for humans, but also for language models. So without that knowledge graph, the agent would struggle to make sense of this fragmented information, which could lead to misinterpretation and poor decisions. It's kind of like having all pieces of a puzzle, but no picture on the box. The agent might guess incorrectly how they fit together, essentially. But with a knowledge graph, you can organize this complexity into a structured, unified format, which makes it also easier for the agent to integrate and use the data. Another advantage of using knowledge graph is that it enables us to go beyond standard retrieval augmented generation systems that typically involve, retrieving relevant chunks of documents for a given question or task. With the knowledge graph, we can take a step further, and we can try to retrieve and integrate context from multiple sources, including real-time sensor data, user interactions, and historical data. And all this will provide a much richer contextual awareness to the agent. The result of this context augmented generation is that it enables the system to generate more accurate, more relevant, and contextually aware responses. And all this is very important in an industrial setting, which involves many complex systems and complex data. The second point I want to highlight for why knowledge graphs are essential to make industrial agents work in practice is traceability and transparency of decisions, especially in heavy asset industry where these two are very, very critical. If you rely on language model alone, it's very hard to really verify why certain decisions were made. And it's very important to consider, again, at the core, that the language model generates answers based on patterns, not facts. And if you rely only on a language model, it's very difficult to trace or verify the accuracy of your output. Even if you know that a mistake has been made, it's very hard to say where that mistake was done in the decision-making process. And of course, when you can't do that, it's very hard to iterate on the system and improve it over time. With the knowledge graph, on the other hand, you have a way to trace and explain the decision-making path, and this is also something that will help us to iterate and improve the solution in case an error or a mistake is done. The third point for why knowledge graphs are essentials for industrial agents is simply because industrial data is not static. Industrial environments are constantly changing, machines break down, sensors update in real time, and production schedules shift. With a knowledge graph, you can manage this temporality of data and ensure language models always work with the most recent data. And finally, the last point I want to highlight is related to access control, where a knowledge graph can, in an efficient way, control what data that is provided to the language model, which is, of course, again, important to meet the access management requirements for enterprise software in industry. These are just some examples and reasons for why we believe a knowledge graph is important to make industrial agents work in practice. Again, I'm emphasizing on making them work in real life, where you need to deal with these different aspects of, access management, traceability, and the complexity of the data. As a final segment in this episode, I want to briefly also comment on some of the requirements for knowledge graphs from an industry perspective. I have to a certain degree covered some of them indirectly while discussing the previous points, but I just wanted to briefly highlight them specifically at the end for clarity. So what are the requirements for a knowledge graph in an industrial setting? First of all, it needs to include robust contextualization pipelines that can bring together and connect industrial data from all sources, whether it's IT or operational or engineering data, like time series, P&ID drawings, equipment logs, maintenance records, 3D models, images, and more. All these must be in a format that is understandable by both humans and AI systems. Secondly, you need to have well-documented APIs, which ensures effective utilization of industrial knowledge graphs. This is important to enable AI agents to effectively use the knowledge graph. So having the connections in itself is not enough. You need to also have ways to effectively communicate with that graph. And finally, the knowledge graph must provide capabilities for data modeling that are performant and flexible, so that we can ensure that the knowledge graph can evolve alongside the dynamic industrial landscapes to maximize the relevance and application of the knowledge graph over time. All right, let's sum up what we have covered in this session. We talked about language models as one of the necessary ingredients you need for an industrial agent, and the importance of selecting an appropriate model suitable for the task, usually guided by industry-relevant evaluation datasets. We didn't go very deep into the details, but again, my colleague Biba will cover this in much more detail in the next episode of this webinar series. Next, we talked about a knowledge graph as another important ingredient to make industrial agents work. By considering the nature of industrial data, the complexity, the dynamic nature of the data, traceability, and access control requirements of heavy asset industry. Now, one thing I want to highlight at the end here is the complementary relationship between language models and knowledge graph. The knowledge graph provides a structured, accurate, and queryable data, while the language model can interpret, reason, and generate natural language explanations. And by combining these two, we have a very powerful synergy where the strength of one technology compensates for the limitation of the other. And I think this is an underestimated synergy in general. In short, by combining the two, you get the best from both worlds. All right. With this, I want to thank you all for watching, and I hope you find it useful. Please don't hesitate to contact us if you have any questions or comments related to this. Also, if you want to learn more about our customers implementing industrial AI in their organization, we invite you to our user conference in October in Houston, Texas. There you will hear from speakers across the world, across industry verticals and ecosystems, and you will also have the opportunity to participate in interactive sessions, workshops, hackathons, and many more. You can learn more about the event and also register by visiting cognite.ai or by scanning the QR code you see on the screen. Once again, thanks for watching and have a great day.